Yes, okay, I'll try to keep it to the 15 minutes that were actually that were agreed. So thank you very much to Amici della Terra and the EDF for inviting me to this presentation. I will try to give you very quickly a presentation of what the Copernicus program is, but also try to move into the topic of today, so greenhouse monitoring, and in particular the methane strategy. So for that, I start to share the presentation. I don't know. Okay, I have to see if it works. Yes, can you confirm that you can see it? Hello?
Yes, Mauro.
Okay, very good. So I will move immediately to this slide. Why Copernicus? So actually Copernicus is the Universe Observation and Monitoring Program, and it was not originally seen as a top-down space program, but really to serve some needs. And if you see here, we see just some of the policies that would require the need of Copernicus. And in most of the cases, we are speaking about environmental aspects, climate change, protecting the planet, monitoring the environment, and so on. So this was really at the basis when we decided to do that. And just, so we spoke about the Copernicus, but this is in some way the structure of the program. So we have an observation capacity, mostly the Sentinels, so satellites that are really built by Copernicus. Then we have also satellites on the top right-hand side that are coming from commercial providers or from national capacities, but the bulk is really in the middle. It's really the services. So the data that are generated, the satellite data, are transformed in useful information, and this can be done in different aspects. So, and I will come later into the different areas where this data can be generated. And all this data generated can also be used for added value products in different areas. When we speak about space in general, I think we know that money is quite important. And just to show that actually when we started with Copernicus or GMES in the beginning, it was in '98, the first idea, and now we have 23 years after, we have an operational program. But this actually, it's also thanks to investment, financing, mostly in the research, and at least until 2014. And from 2014, we got into operational budget. So most of the budget for Copernicus is coming from the European Union, and also a big part coming from the European Space Agency. But it's true, when we speak about European Space Agency and European Union, it's meaning European member states. So they're putting the money there. So it's really an investment by EU member states in that respect. So we see that in the period 2014-2020, we had 4.3 billions that were dedicated to Copernicus. And now in the period 2021 to 2027, there will be an investment of 5.4 billion. So again, an increase of budget in what we are doing. The contribution, so this is one big part. I have to say the ESA part is correspond to more or less 25-30% of additional budget to this, in particular for the development of satellites. What are the drivers? So the drivers, at least in the current European Commission, is to have a green, digital, and resilient transition. So whatever is done at the European Commission at this moment in time is really to go along these priorities. So you see also how they are declined also in 6 more detailed aspects. And indeed, the European Green Deal that you probably heard about several times is at the top of the priorities of the European Commission. So speaking about space in support of environment, in support of observation, greenhouse gases monitoring, and so on, is clearly part of the objectives of the current European Commission. So the 4 building blocks of Copernicus, it's about data acquisition, it's about services that are generated, access and distribution of the data, and how this data could be taken up by the user. So I will treat very briefly each one of these blocks, and then detail more on where we're going for the methane strategy. If we speak about data acquisition, as I said before, it's about satellite observation mostly, but also in situ capacities. So we have also a long series of instruments that can measure, for example, pollution at the ground level, and these are complementing what the satellites are doing. And when you speak about the satellites, there are commercial satellites existing, but also the Sentinel missions that were also mentioned by Simonetta just before me. And here you see the families of the Sentinels. So they are called 1, 2, 3, 4, 5, 5P, and actually and 6. Of these, we have 2 versions of Sentinel-1 flying, 2 versions of Sentinel-2, 2 versions of Sentinel-3. One version of Sentinel-5 actually is a precursor, and so the 5P that is indicated there, and 1 version of Sentinel-6, the Sentinel-6 Mike Freilich. Out of that, if we look into greenhouse monitoring, those that are more relevant will be Sentinel-4 and Sentinel-5, because will be those that will look more into the composition of the atmosphere and in the different pollutants, including CO2 clearly, but also methane gases. These are the Sentinels that we have today, but we are also planning to go into new ones. So I will not detail too much on this slide that was already mentioned by Simonetta, but just to say that practically all the new 6 missions that are foreseen to complement the Sentinels already existing are contributing clearly to climate change monitoring in some way. And in particular, the CO2M that will be mostly to monitor anthropogenic CO2 emission. There are already several missions monitoring CO2, but this is really anthropogenic emissions, really looking at sources of CO2 emissions. And it is expected that it will fly in a formation of 2 or 3 satellites in the period 2025, 2026, in order to have carbon stock monitoring before COP 2028. But also all the other missions described here are, for example, very important for the Arctic monitoring, or also for monitoring of vegetation, biomasses, and so on. But all these data generated by the satellites have to be used for what we call the services. Services here, they are declined in 6 ones. So clearly, we have a service that is looking into climate change aspects, in marine monitoring, land monitoring, so land management monitoring, atmosphere monitoring, but also emergency management or security. And even these 2, emergency and security, they seem not to be linked to climate change or aspects, or to environmental aspects. But we have to understand that even emergency management is more and more linked to extreme events that are linked to climate change, and also security, where we look, for example, to support of EU external action, so in support of populations that are in trouble outside of the EU, I don't know, in Africa or somewhere else. In some cases, also the difficult situations, security situation, conflict situation, are really based on climate change issues, because climate change creates also pressure on these populations. They generate conflicts, droughts, lack of water, and so on. So also the security aspects are linked to climate change aspect. These services and also the satellite generate a lot of information and a lot of data. And all these data are following the principle of being full, open, and free. And this is very good, but at the same time, it creates an issue. And the issue is too much data, how to digest that, how to distribute this data. So we're speaking about massive amounts of data, and these have to be distributed. For this reason, it's not just sufficient to generate data, but we have also to disseminate that. And we are looking into potential infrastructures. In order to do that, we are looking into new technologies to integrate also capacity for artificial intelligence, high performance computing, quantum computers for the future, and so on, in order to make them use. The interaction with the different countries is also important. And some of these have been able really to mirror what Copernicus is doing. And I imagine that Andrea later might speak about the Copernicus mirror and how these things could also have been translated at Italian level. So in order to see how what is generated at European level could even be expanded on the national needs. And again, it's important to generate satellite data, to transform them into information, to distribute the data, but also to help people to use them. So we have also to generate, first of all, the knowledge to use it. So to tell people what is possible to get, how to use the data, and to create the opportunities also of new businesses, because the data that are generated by Copernicus can be really used by small and medium enterprises, or people having good ideas starting from universities, creating spin-offs on those examples. And there are more and more examples on companies that are really based on the fact that they have at their disposal a big program that provides them with full and open data. And this is creation of jobs. So it's really part also of the strategy that we have at the European Union in order to create more and more job opportunities. And in that respect, we have also some additional capacities, additional tools. Here in this slide, you see this USPA, that is a new agency that is has been put in place in order to facilitate the market uptake, and also a new initiative that is called Cassini that will help to invest in startups, in SMEs, and their scaling up. Now I want really to get into the methane part, and the starting point is the atmosphere monitoring service. It's one of the 6 services that are foreseen in Copernicus, and is the one that's really looking at the atmospheric composition. This task, so this service, is delegated to an entity that is called ECMWF. And actually has this capacity to monitor, to use the data in order to generate observations. You see here in this slide the fact that the satellite data and the in situ data that you see really at the bottom on the left-hand side can be transformed in what is in the middle. So what are some models, but also some maps that can show you the distribution of generated emissions or composition of the atmosphere. But it's not just that. All this information can be used then in different areas, for example, like in agriculture, or to generate, for example, some applications for iPhones where you can identify the air quality, or many other aspects that are moving from the global to the European and to the local level. So through all this observation, is really possible to improve all these capacities. And if we want to look very quickly to a portfolio of potential products that are generated by the atmosphere service of Copernicus, you can see that we can have bottom-up emissions and surface fluxes of greenhouse gases. We can have global analysis and forecast and reanalysis. We can look at solar radiation, climate forcing, ozone layer, European air quality, and products in support of policy users. So there is really a big number of products that are generated, and if you want to see to have more details about that, I really invite you to visit the website of the Copernicus Atmosphere Monitoring Service, and you see at the top the link where you can get information about that. So what is the link with methane? Actually, with methane, there are more and more capacities to look what's happening. So with the emissions of this gas, where it's coming from, we can have high-resolution satellite observations of methane. Already on board of Sentinel-5P Tropomi instrument, we have a possibility for methane observation worldwide, with also quite important resolution, and also taking into account several biases like the cloud, surface temperature, surface reflectance, and so on. We have also other observations that are taken into account, top-down, meaning from the satellites. So where you can have monthly averages that are analyzed. They are based also on surface and satellite that are not just European, with different resolutions, and they can also be related to different components linked to wildfires, wastelands, rise, and other. And then there is a bottom-up CO2 emission, where you can have also analysis at the ground. So in order to compare what is coming from the satellites and what is measured on the surface of the ground. All these elements put together, all these observations, are very helpful because they can help not only to see the situation, but also to make forecasts. So to foresee what could be the expected concentration of methane in the world, taking into account also the weather conditions. So we can have the historical past of what happened, but also to anticipate what will happen in the future. And as said, all this depends on measured emissions, but also on weather and evolving weather conditions. And this is also important because it's not just about forecasting, it's about also identifying anomalies. Because by predicting something that could happen in the past, we can maybe identify some anomalies that are against the prediction, and this could ring a bell, say, there is a problem, there is a leakage of methane or other things. So all these elements are under reflection, and more we are getting to know what the different technologies on Earth observation can do in this area, and methane observation will become more and more something that will be useful and possible in the future. This slide is not anymore about methane, but it's more CO2. Why that? Because as said, one of the most ambitious plans that we have for the future is the CO2 monitoring capacity in Copernicus. So it will be composed of observation of CO2 and atmospheric emissions, so through a constellation of satellites, but at the same time with on-the-ground observations, and through inverse modeling, it will be possible to identify which are the sources of anthropogenic emissions, because this would be very important really to see not the average emission, but really where are the sources. So in a way that we could monitor, we could intervene and to see if, for example, some recommendations are respected, or if we can really intervene in some cases. And the last slide I have is about the methane strategy that is ongoing at this moment. So there are communications, there are different activities at the European Commission level, but the main aspects of this strategy is on one side to improve the measurement, reporting and verification, as well as leak detection and repair. Second pillar is review of EU climate and environmental legislation. Third one is establish international methane emission observatory, and this could also is a place where the use of satellite could be very important, and then clearly targeted support for biogas from organic waste and residues. These are some of the elements that are really included in this strategy, and this IMEO, International Methane Emission Observatory, is one of the elements for the recipe of this strategy. So I try to give you a flavor of Copernicus, of the services on atmosphere monitoring, on what we can do on methane, on CO2. I hope that it was not too much. And in case you need more information, I really invite you to visit the Copernicus, Copernicus.eu website. That could be where you can eventually find your answer, or it can be a starting point to bring you to other websites that can give you more detailed information on different aspects. And with that, I would end my presentation.